You're listening to a special AI-powered training session generated based on my original research and training documents. While the voices you are about to hear are AI-generated, the insights come directly from my verified material.
Welcome to the Epoch Zero Show. Today we are unpacking Module 1.4.2, Reasoning Models and Agentic AI 2024-2026.
Around mid-2024, the entire game in artificial intelligence changed. The race wasn't about building bigger and bigger models anymore. The new frontier, the new challenge, was to build models that could actually think longer, that could reason.
Now, this shift didn't happen in a vacuum. It was born of necessity. You see, the easy gains from just scaling up model size, they were drying up. The standard benchmarks were starting to stagnate. It was clear a new approach was needed to get things moving again. And that new approach came to be known as the thinking longer paradigm. The whole strategy pivoted. Instead of focusing on raw model size, the new idea was to dedicate a whole lot more computation time right at the moment a user asks a question. That crucial step, that's called inference.
So let's compare. The old way was simple. You pre-trained a massive model and you expected fast answers. The new way, well, it allows a model to deliberate, to think internally for seconds, even minutes, before it gives you a final answer. This was a direct trade-off. You gave up speed for a shot at better accuracy.
The technical term for this is inference time scaling, and it's really the core innovation of this entire period. Instead of burning all your compute in the one-time training phase, you spend a big chunk of it every single time a user asks a question, all for a higher quality result.
Now, a great way to think about this is AlphaGo's Monte Carlo tree search. Remember that? AlphaGo didn't just look at the board and make a move, no. It ran millions of internal simulations to play out the future, and only then did it pick the best path. These new reasoning models do the exact same thing, but for logic problems. They run internal simulations to find the best answer.
And the first major product to really embody this was OpenAI's O1A model, which they previewed in September 2024. It was trained totally differently. It wasn't just predicting the next word. It was rewarded for producing logical, step-by-step chains of reasoning. Users literally saw a thinking ... indicator on their screen. And the cost? It was substantial, 3 to 10 times more than GPT-4 Turbo. That was the price of deliberation.
So, this new capability led to a huge surge of excitement and some absolutely extraordinary benchmark claims. The industry dove headfirst into a new hype cycle. This one was centered on verifiable domains like math and coding, places where you could prove an answer was either right or wrong, no ambiguity.
Take the American Invitational Mathematics Examination. This is a notoriously tough Math Olympiad test. GPT-4 scored just 13.4%. The O1 model, though, it scored 83.3%. Now, this was not an incremental improvement. This was a quantum leap in performance on a formal reasoning task. Then came the successor model, O3, announced late in 2024. It pushed things even further. On the Codeforce's competitive programming benchmark, it hit an ELO rating of 2727. To put that in perspective, that put it in the top 175 human competitive programmers in the entire world. A machine was now world-class at coding competitions.
But the most significant claim, the one that started a firestorm of debate, came from the ARC-AGI benchmark. This thing was designed to test pure generalization on novel puzzles. And in its high compute setting, OpenAI announced that O3 scored 87.5%. That number changed everything.
Why? Because the creator of the benchmark himself, Francois Chollet, had already said that any score over 85% could be considered evidence of AGI-like reasoning. So for the first time, a major lab claimed its system had crossed a publicly defined AGI threshold. The hype was at its absolute peak. And then came the reality check. The claims were spectacular, no doubt about it, but the real-world performance was far more complicated. As leaders, this is where we have to look past the announcements and do our own diligence.
The central question became impossible to ignore. Did these incredible scores on abstract tests actually translate to real-world utility? Is getting a high score on a math test the same thing as being reliable in a messy, complex business environment?
The answers started to trickle out over the next year. In December 2024, OpenAI made its 87.5% claim, but by January of 2026, the ARC Prize Foundation ran their own independent tests. Their results were significantly lower.
Around that same time, industry analysts started publishing warnings that vendor benchmarks just weren't translating to enterprise value. The gap was so stark that critics cited in Fortune magazine called the initial results manipulative and disgraceful. The problem seemed to be a big difference between a pre-release model that was likely tuned for the test and the public model everyone else got to test.
The lesson for every single applied AI leader was etched in stone. High benchmark performance from a vendor does not guarantee real-world effectiveness. You have to assume a gap exists between their lab and your production environment. Never trust vendor benchmarks alone.
Now, beyond the controversy, if you just did a sober analysis of the model, you'd find a series of very hard trade-offs. These are the practical, on-the-ground limitations that define where this technology can and can't be used. First, reliability. For all its power, O3 still made basic common-sense mistakes and reasoning errors. Second, cost. The high compute settings were 10 to 50 times more expensive. Third, latency. A 10 to 60-second wait time is simply unusable for anything interactive. And finally, transparency. The internal reasoning was a complete black box, making it almost impossible to audit.
This really illustrates the problem of diminishing returns. You're looking at an enormous increase in cost, maybe 30 times more expensive, for what might only be a 15% gain in accuracy on a given task. The economics of that, well, they severely restrict where you can use this. The ROI just isn't there for most problems.
So this brings us to the strategic application rule. For you as a leader, given these powerful capabilities and these very real limitations, where does this expensive, slow, but powerful tool actually fit into a business strategy?
You use it in high-stakes, verifiable domains, places where accuracy is everything and cost is a secondary concern. Think about legal analysis, medical research, complex code debugging. These are domains where waiting 60 seconds for a much better answer is not only acceptable, it's desirable.
You do not use it for real-time applications like chatbots. That latency would kill the user experience. You do not use it for high-volume, cost-sensitive work. And you absolutely do not use it in systems that require auditability because its reasoning is opaque. Using it in these contexts is a strategic error.
This leaves us with one clear directive. Your role as a leader is to pilot before you commit. You have to test these models on your own data, in your own workflows. Never trust vendor benchmarks alone.